All right, kiddos, you have, I was supposed to say assignment 2 there. You've got 2 assignments due March 23rd. The new assignment that I went over last time, the economic order quantity model with stochastic demand, it's due April 5th. And that's one where you basically open a spreadsheet template, save it, the file name with your name. You download the data corresponding to you, and all that's in a module in Canvas, and then you follow a video tutorial on how to construct the spreadsheet where you're simulating what happens if you follow that EOQ rule with stochastic demand. What if you followed it in the past? What would have been the outcome for you? So you see in lecture set D, here's assignment on EOQ with stochastic demand. Here's the spreadsheet you download. Here's your student-specific data, the video tutorial, and then you're going to upload your Excel file there. Okay. What you want to do for today, we're starting something very new, optimization. And you want to, if you have your computer, if you don't have your computer, that's fine. It just means like you might have to go back later on a computer and go over the video again. You want to download this template that's going to look like this. You don't need to download the slides. I only have 3 slides, but those slides are there for you, so you don't have to take notes or anything. Right. What we're doing here is we're talking about, this is the subject of optimization. And it's when we're dealing with a problem where to find the best solution, you have to crunch a bunch of numbers, and it's just not something you can do in your head. It's not something you can calculate by hand. You can set up the problem, but as far as finding the answer, that's pretty difficult. And so we let computer algorithms do that. And that's what computer algorithms are good for. Humans are good at the abstract part. We can conceptualize problems. We can put a structure to the problems. That's something computers can't do. But what computers can do is execute an algorithm. And the way I'm going to teach this is it's going to be a learn as you go. So it's kind of like with sports, probably the worst way to learn a sport is to attend a bunch of PowerPoint presentations first, going over the theory of the sport and the rules of the sport and the technique of the sport. The best thing to do is just get out there and start playing and learn the rules as you go. You just learn faster like that. So it's going to start off where it might feel like we're going fast. We're going to just start building these models that some of you have never seen before. I'm going to be showing notation to you as we go. It'll be a little confusing at first, but then once you're doing both at the same time, then we go back and review it, it'll all start clicking much better. It's much better than the alternative of me throwing up a bunch of slides that are meaningless to you at the start. And this whole series of lectures on optimization is going to be building on each other. And so this is the kind of thing where if you fall behind, it can be really, really hard to catch up. So it's something you really want to keep up with. And we're going to be, reason to have you bring your laptops here is I'm going to be making the models on here, but I'll have y'all make it on your computer there, just because, doing things with your hands, actually implementing it yourself will help you learn better. And of course, those of you out there in the World Wide Web, you can do that as well. Looked like from last lecture, me just having the screen up here allowed you to see it perfectly fine, but I'm also recording the actual screen that I can make a different style video, so you have to let me know if you're having trouble following the spreadsheets. All right, we ready? Okay. So what we're going to do is we're going to start with a really simple problem and just keep adding other things to it as we go until we get a bigger problem. We're starting off, we're going right back to our master production schedule, where we're basically asking the question, how much should we produce? and we're going to apply optimization to that. But then we're going to take the optimization to use it for logistical models like transport models, like figuring out which trucks should go to which distribution centers to deliver to which stores. The kind of algorithms that, say, UPS is spending millions on crunching every day to figure out where the packages should go, what routes the UPS driver should take, things like that. We're not going to look at the mathematics behind the optimization algorithms. We're just going to learn how to build the models and execute them. So this is where we're starting with this really simple model where I've got, I'm recreating the master schedule here, and I've got this thing that says demand, forecast plus orders. So for now on, you don't have to keep forecasts and customer orders separate. They're going to be one, demand. If we're talking about how much, if we're making chewing gum, you know, we're thinking about how many packs or pallets of chewing gum that we're planning that we think will sell each month. And we're sticking with our March through July template. We're making monthly decisions, and what we have to figure out right here is how much to produce each month. And now we're bringing in cost. And we're just going to start off with a scenario where we have, this is the cost of production per unit for each month. And I just made up numbers to put in there. And we're starting with a ridiculously simple model that you don't need an algorithm for. And this is where we're starting to introduce notation. When we're building these optimization models, there's lots of equations there. But all you really need to know is what everything stands for and to be able to conceptualize the model in your mind. So we're starting with this really simple thing where I is going to denote months. So we have March, April, May, June, July, so we got 5 months. So if I is 1, we're talking about March. If I is 5, we're talking about July. And then Xi is the number of units we produce each month. So we need to figure out how much to produce in March, how much to produce in April. Those are our decision variables. It's our Xi. So X2 would be the number of units we produce in the second month, which is April. And then we have little ci per unit production costs in month I. So like this right here is saying it costs $10 to produce 1 unit in March, $9 to produce 1 unit in April. And then we have demand, how much we need each month, D. So D3 means how much we need in the third month. That's May, so D3 would be 350. Now in this model that we're starting with, we're first going to say there are no inventories. And so the decision's really pretty simple. If we know we're going to need 300 units in April and we can't hold any inventories for March, we know we're going to need to produce 300 in April and 350 in May and 300 in June and 300 in July. Obviously the question's going to get more complicated as we go, but we're starting simple. And the equation describing our optimization algorithm is this. We're wanting to minimize. We're minimizing our cost here. And underneath the min is Xi. So that means we're minimizing costs by choosing the optimal values of Xi. We can't control Ci, the cost per unit. We can't control Di, demand per time period. We control how much to produce each period, Xi. So we're minimizing by choosing the optimal values of Xi. We're minimizing the sum of Ci times Xi, the total cost of production. C1 times X1 is the cost of producing everything that we produce in March. C2 times X2 is the cost of producing everything in April. And so we're summing monthly costs across all I 1, 2, 3, 4, 5 to get a total cost across all those months. And of course, if we just told the computer minimize costs, and that's all we told it, it would say produce 0 units of Xi, because that minimizes cost. And actually, if you didn't put any other constraints on it, it would say make Xi negative infinity, because that makes total cost negative infinity. And so what this means is the computer doesn't understand the problem. All we have to do is communicate to the computer what the problem really is. And we do that by arranging certain matrices. As we'll see, matrices that we describe succinctly as this. And so we know we need to tell the computer that each month we have to meet demand. So we're going to tell the computer, yeah, we want you to minimize costs, subject to the constraint that each month we produce at least enough to meet demand. It may seem strange, I've got greater than or equal to demand. Yeah, we could say equals demand, but there's some reasons why we do that. Typically, if you don't, there might be a reason sometimes you want to produce more, but let the computer tell you that to just choose DI. And so that's our simple problem to begin with. So what we're going to do now is we're going to construct this problem in Excel and see if we can get Excel to solve it. You know, I haven't seen if this, usually we use a tool in Excel called Solver. I haven't checked to see if it's on this one yet. We don't know if it's on that one yet. That's something we gotta go through. But in all optimization problems that we do in this class, the structure of the problem is going to be set up in the same way in the spreadsheet. And it may at first look kind of awkward and weird, but there's a reason to it. Once you understand the structure of how we set it up, it's much easier to both add things to it, to construct new models, and especially to figure out where your model may be wrong. So I mean, we could take this spreadsheet right here and put solver in it, put equation stuff into it, but we're going to do a totally different outline. And what we're going to do here, I'm going to go to the computer, I'm going to start constructing it, and you construct it with me. You have to let me know if I'm moving too fast or something. Going back here, so I want to conceptualize this different in a spreadsheet. So I'm going to start a new spreadsheet here. And what I'd say you might want to do is definitely save this spreadsheet, because you can just keep adding to it. And so like every class period will kind of have a different sheet. And then you know you have this one sheet that has all your different models that goes from simple to less simple to complex to more complex. And I'll call this Optim 1. So I just clicked on the sheet name there to give it a name. And in these models, I'm always going to have one row that has all my decision variables. And later on, there'll be lots of different types of decision variables. But here, it's just 5. But we're going to put them all on one row. So we have our decision variables. And our decision variables are how much we produce in March through July. And right now, we don't know what those values would be, so I'm just going to put zeros there. And maybe I'll make a rule that I always put my row of decision variables in bold. We're going to be doing something called linear programming, where the cost function is really simple. So anytime we have a decision variable, there's a constant per unit cost associated with that decision variable. Meaning, when we produce 1, its cost there, the cost is C1, the cost of producing there. So if C1 is 5, it costs 5 to produce the first one, 5 to produce the second one. We're not going to have like a quadratic formula or anything for total cost. You could, but that's not the kind of model we're building. So right underneath it, we want the per unit cost of the decision variables. And we don't really have a real problem set up here yet, so let's just go say there are 8, 9, 10, 11, 12. So the cost of producing a unit in April is 9, the cost of producing a unit in July is 12. And that would suggest maybe we might want to produce whatever for our demand in July, we might want to produce it earlier in May, but right now we don't allow inventory. So the model's not set up yet to let us produce in May to sell in July. We're wanting to minimize total cost. Well, the cost of producing in March is going to be how much we produce times its per unit cost, that times that. Cost of producing in April is that times that. And of course, we could go in and say equals this times this, plus this times this, plus this times this. But instead, we're going to use a sum product formula that lets us do it much easier. That's one reason we're putting these things in single rows. So here, sum product. Sum product meaning we're just taking a bunch of products and summing them up. We're doing the sum product of how much we produce each month times the per unit cost each month. So this formula then is going to go this times this, plus this times this, plus this times this, plus this times this, plus this times that. And it's going to sum them up. And of course, right now it's 0 because we're not producing anything. If our formula is right, if we put 10 here, should be 10 times 80, 80. If we then go over here and put 10, it should add 123 to it, 200. Right now, it doesn't matter what values you put in there for the decision variables. So we're minimizing total cost, subject to the constraint that every month we have to produce at least enough to meet our demand. And here's how we're going to add those demand constraints in. We need a constraint for March that says in March we produce at least enough to meet demand. We need a constraint for April saying in April we produce at least enough to meet demand. In May, in June, July. And we're going to arrange all this so that we could easily use our sum product formula. Now what I'm going to want here, I'm going to want this cell right here to say how much we're producing in March. And for me to do that, and I know I want to use the sum product formula, I'm going to put a 1 under March and zeros elsewhere. And then as you can probably guess, I'm going to do a sum product formula with this and that. Now I'm starting to notice that we're going to have lots of sum product. We'll be doing models where we may have 100 sum product formulas in there. And I'm going to be calling those decision variables a lot. And so now I'm seeing it may be really convenient to give those decision variables a name. So I'm going to do that now. These are my decision variables. And I'm going to give it a name by coming up here, upper left-hand corner, and maybe, let's see if it'll let me call it DEC VAR. Yep. Okay, so now anytime I need to call those decision variables, I type DEC VAR. And then total production for March will just be the sum product of that row, a row of indicator variables indicating which month it is. There's only a one for March, so it's telling us it's March. Sum product of that and DEC VAR. Again. And so what this is going to do, that sum product formula is going to go this times this, plus this times this, plus this times this, plus this times this, plus this times this. Since there's only a 1 here, the answer is going to give us that times that. The rest are zeros. 10 times 1 should give us 10. Our production constraint says that production in March should be greater than or equal to, and I'm putting greater than or equal to there. That's for me. That's something we're never going to tell the computer. That's to remind me what the constraint is. And then we have a demand constraint. Let's just say 300. So this constraint here says that production in March should exceed demand in March. Maybe this will help. I'll put production, I'll put demand. Now, of course, right now we're only producing 10 in March. That does not exceed demand of 300, so the computer is going to give us a different answer. Let's go ahead and say that demand's going to be 300 in each month. And this sum product formula is going to be the same. So I want to copy and paste that for all months. So I highlighted those three things. I'm going to copy by Control C on a PC, Command C on a Mac. No college graduate should be going up to Edit, Copy. Control C, PC, Command C on Mac. I'm going to hold down the Shift key. I'm going to go down for all months. And then I'm going to paste on PC, Control V, on a Mac, Command V. And then I have to make sure I have the right numbers here for these other months. And remember, all these things these are just rows where 1 indicates which month it is. I had a 1 here in March because it was March. I had 0 otherwise because those are different months. So I know in April, this is the month of April, so I want a 1 under April. This is May, so I want a 1 under May. And you can see we're just making a diagonal matrix like this. And zeros are going to be everywhere else. And for this model, that's all we're really going to need. And this is the structure of every model we're going to use. So when we add decision variables, we're going to be adding stuff there. We're going to be adding costs to it. We're going to have to expand our constraint matrices. But the format is basically the same.
How did you fill it in again?
How did I fill out this whole thing here? So what I did was I said, if I put a 1 under March here, because the way the sum product formula works, it's going to give me production for March, because it's going to go this times this plus this times that, and all the rest of them are zeros. Like down here in July, if I put a 1 here and zeros elsewhere, it's going to give me production for July, because the sum product formula is going to go this times this, plus that times that, plus that times that, but these are all zeros, so it's going to give me production for July. And so basically, whenever it's June here, whenever it's June row, I need a 1 under the June column. In the May row, I need a 1 under the May column. In the April row, I need a 1 under the April column. And zeros elsewhere. All right, then Excel has a solver routine, has an algorithm we can use to solve these kind of things. It's not always installed on it. So I haven't checked on this computer yet. Usually it's under data, I think. Forecast sheet. I don't see it, so sometimes it's under data developer. It's usually not automatically installed. And if it isn't, you need to, it's an add-on. And sometimes I just kind of know where it is. Sometimes I have to Google it. But if you're not sure on your computer, you can always Google add solver to Excel. Often in the past it's been, let's see. Yes, I'm going to file more options. Okay, so I went to some kind of thing like file options. I'm going to go to add-ins on a Mac. You usually go to the Excel thing on the upper, like if you go to Excel system preferences, might say add-ins. What are you seeing?
It's under on Mac. It's under tools on the top toolbar.
Okay, so in Mac it's under tools, and then it says add-ins.
Yeah.
Okay, so in Mac, go to Tools at the top, then Add-ins. Okay, so I went to Add-ins, and there's this Solver add-in. Now, if I don't, it may not let me here without administrative privileges. We'll see, but you somehow want to find Add-ins, and then you get the Solver add-in. And I remember on PCs, you got to hit Go instead of, yeah. Solver add-in. Okay. Yeah, and so now when I go to data, I can find the solver. Is anybody having trouble getting it? Meaning every single person has the solver now. Sam? Okay. It's never been that easy. Okay, so now I'm going to go, let's open up Solver. And we set up these model sampling, so that's an objective. Our objective is to minimize cost by changing which variables are decision variables, and then we have these constraints. Our objective function is going to be, we're minimizing total costs, so I'm going to choose wherever my total cost formula is. And then we want to minimize it. By changing which variables? I don't know if it'll let me do that. Well, let's go, I want to highlight all my decision variables here. And then subject to the constraints. There's no constraints there yet. And by the way, this is always going, I think Excel will be set up where it always assumes your decision variables should be greater than or equal to 0. If you want to change that, you got to go to options and unselect it. So we don't need to tell Excel that XI's, how much we produce each month, have to be positive. All right, I'm going to add a constraint here. Whoa. Okay. Add a constraint. And we've got these constraints here where all of these things need to be greater than or equal to these things. So I can just come over here and say all of these have to be greater than or equal to all of those. There's different algorithms you can choose there. We're doing something called linear program. It's the simple, about as simple as you can get. And so we're choosing simplex LP. You should get the same number no matter what you use. This one's just quicker. And then we solve. Quickly found a solution. Ask you want to keep it. And obviously that didn't work, did it? Maybe I pressed the wrong thing. What's that?
Were you meaning to use July's or the production?
Keeps over. Where was the error?
Like you use July's numbers in column F instead of the production in column G. So you're
B2.
So the initial.
Oh, I see. Yeah. Oh, yeah. So I said that this has to be greater than 300, and it couldn't find a thing there. Production has to be greater than 300. And of course, there was only one solution here because we can't store any inventories. If we want 300 units in May, we got to produce 300 units in May because we can't store anything. Is anybody able not get it to run to get that solution? Okay, well now we're going to make it more complicated. Now we want to be able to store things if we need to. We need to be able to store inventory, so we're going to add that to it. And our conceptual model is changing now. Now, in addition to choosing how much we produce each month, we're also choosing how much we're going to store each month, store in inventory. And so we've got this variable I, subscript I, so I2 would be like ending inventories in April, the second month. So we've got more decision variables, and there's a cost of holding inventory. Now, HI is the cost of holding inventories in month I. So H4 is the per unit cost of holding inventories in June. So now when we're minimizing total cost, we're minimizing both production cost and holding cost. And we have to find some way of telling in Excel what an inventory is. Excel just doesn't automatically know what an inventory is, and you can only communicate these things through math. And so we start with this equation. We know that the amount of inventory, and by the way, whenever you introduce information to Excel, it's almost always through a constraint. Constraints are a way of telling Excel the nature of the problem. And so what we know, the ending inventory in any month is going to equal inventory you begin with, which is ending inventory in the previous month, plus however much you produce, minus however much you sold. And so ending inventory in April is going to equal ending inventory in March, plus production in April, minus demand in April. And that's just telling Excel ending inventories April is how much stuff you had and produced minus how much you sold. That's simple. And there's a number of different ways you can put this constraint into Excel. The one we're going to be doing is kind of like this. If we take this and make an equation, we say I subscript I equals I subscript I minus 1. Beginning inventory last month, plus XI production this month, minus DI production this month. But we're going to rearrange it because I just know in advance I want to have demand on the end. You remember how when we set up the demand constraint, demand was on the end of the sheet? We're doing the same thing here. And when I rearrange this to have DI on the right hand side, you've got XI plus XI minus 1 minus II. And so now we're minimizing costs. We're minimizing costs by choosing how much to produce, how much inventory to keep. The cost formula is this, the sum of all production and holding costs. And now our constraint is this. We don't have to add like a second set of constraints. We're just modifying our old constraint to do this. And we know this works because, so if you look at this and you say, well, that just tells Excel what inventories are. How do we also tell Excel we need to have at least enough to meet demand? Enough inventories and production. Well, you just have to remember that one thing that sales knows is that production and inventories cost money. So it's not going to want an XI or an II just for fun. It's going to want those to be as low as they can. And then if you tell them these have to equal DI, you're simultaneously telling them what inventory, telling Excel what inventories are, and that you have enough stuff to meet demand. Let's add this. And the way I'd like to add it, I want to create a new sheet that's just like this, but we're going to add to it so you have your old sheet to go back to. So I'm going to go down here to Optim 1 and I'm going to right click and I'm going to say copy. I want to make a copy of the sheet and move it to the end. So I went down to the sheet, Optim 1 here, right click copy. Went up here, say create a copy, move to end, And I'm just going to call it Optum 2. So every time we add to this model, we're going to make it in a new sheet, so you keep your old model and add stuff to it. Okay. We still have our old decision variables, but now we have some new decision variables, which are the inventories. And because we have different types of decision variables now, I'm going to add a little formatting to the sheet so I can better differentiate them. So I just put a row there. You probably already had the row, but I'm going to say this is production. And I'm going to give all these a pretty blue. We're going to have similar decision variables for inventories. And by the way, I know I'm going to have 5 more decision variables, and so I can just see ahead that I'm going to want to insert 5 columns here. So I'm going to come up here, and I'm going to right-click. I don't want to insert cells. I want to right-click, insert. 1, 2, 3, 4, 5. Control Y is redo. On PC, Command Y is redo. In Excel. I'm sorry, on Mac. We have production decision variables. Now we have inventory decision variables. I'm going to give these a different color. Excel's going to start them off. We've got to give them a value, so I'm just going to start them off with zeros. And let's just say our holding costs are, I don't know, let's say 2 right now. Now, usually when I'm teaching this in a class, we're really right together. Someone can help you if you fall behind. I can come around more easily. So if the way I'm doing this isn't working with you, going too fast or something, and you're scared to say it in class, just email me or send me out to class. So this would be how much ending inventory we have in April. This is how much ending inventory we would have in June. This is the cost of holding inventory in April. This is the cost of holding inventory in June. And one nice thing about having all decision variables on one row and then their costs on the row right underneath it, we can just modify our sum product formula and to calculate total cost. Now remember, we had named the decision variables DECVAR, it was just production, so we have to go back and change that definition so it knows that all decision variables are both production and inventory. If you have to delete a name of a variable or change the name, let's see, usually you go up to formulas, formulas, name manager. I think it's the same way on Macs. Okay, and sometimes using different sheets with the same names can result in problems. I think these things are now such that you can use the same name on different worksheets. It looks like this because it has scope here. It's got DECVAR just for Optum 2. Let's see if we can just edit that. And now I'm saying all my decision variables are all the production variables and all the inventory variables. Our sum product formula is now our decision variables and their respective per unit cost. We can check to see if that formula, yes? What'd you say? You're not getting the same thing? Okay. Are you getting a number at all? Let me come look at it.
Like mine didn't, like the deck bar, it didn't carry it over to the other side.
Oh.
I don't know what I did.
Go to, let me see, define name. Yeah. And then select over there and try selecting it again.
And all of that.
Yeah.
It just says decision underscore variable.
Try, go to define name. Delete decision, delete that. Tell you what, now hit close. Select all, have you got all the decision variables selected? Name it DECVAR2. And then in the sum product formula, change DECVAR to DECVAR2.
Which one?
B1, I'm sorry, the total cost. That got it?
Yeah.
Yeah.
Thank you.
Mm-hmm. Don't need to apologize. You weren't supposed to know this coming in. Anybody else? Yeah.
Yeah, mine's not working. Like I'll get it here, and then hit OK. But then whenever I go back here and look, it's just this thing, or this one.
If you name it DECVAR2.
Yeah, let's not keep the same name across different worksheets. So I'm going to come over here, instead of DECVAR, I'm going to name it DECVAR2. Okay. So I'm going back to my name manager. Okay, so I went to name manager and I deleted deck var. And then I'm coming over here to all my decision variables and I'm gonna name it deck var 2 to correspond to Optum 2 sheet. Then up here in my sum product formula, dec var 2. And, you know, sometimes like I might want to make sure it's working, so I know it should be maybe I'll add one inventory of March to see if total cost really does go up by 2, and yeah. Okay. I'll finish building the sheet, then I can come around. Okay, so now I've got this constraint. It says xi plus I minus 1 minus I, maybe I shouldn't have used I, equals demand. So this is saying, and I'm going to do the last month first. So I'm going to go ahead and change, here, I'm going to go ahead and make all of these zeros to start with. So everything from March, all over there, is going to be zeros. And then I'm going to want, this is what my constraint should look like. Something where we had greater than equal to something, but now our constraint says equal to something. So I'm going to come over here and change the greater than equal to equal. I may need to put a, what do you call that symbol? That thing. I don't even know what that is. So I can put equal sign. Because if you just say equal, it wants you to do a formula. Well, maybe not. Okay, equal sign. We want a left-hand side equal to a right-hand side. Our equation says the right-hand side is demand for each month, so we're cool there. Demand's still 300. I haven't said anything about that changing. Well, we know on the left-hand side, we want there to be xi. So I'm going to start with the last month. And I'll tell you what, I'm going to come over here so I can always see my months. I'm going to do this. I'm going to come to right there, and I'm going to do a freeze panes. So I'm doing a freeze panes thing so that no matter how far I go over here, I can always see what month it is. No matter how far down I go, I can always see what April is. I just went to the place I wanted to freeze and said freeze them panes. Okay, so again, we want a left-hand side equal to a right-hand side. Let's start with July. So D for July, demand in July, has to equal, we got to have production in July. So I'm going to put a 1 under production in July. So I know the left-hand side is going to go 1 times 300, or whatever production there is, plus inventory from last period. So we're in July. I want to add inventory from last period. So I'm coming over here, putting a 1 under June. And then subtract inventories this month. And so instead of a 1, I'm going to do a negative 1. This formula isn't right. We've changed the sheet, so I have to change the formula. I know this should be the sum product of all of those indicators right there, and DEC VAR 2.
All of which indicators you said?
What's that?
All of the bottom of the line?
Yep. And it's kind of confusing. Don't worry, we're going to just keep doing things like this over and over and over. It'll kind of become second nature if you're keeping up. But imagine having a product and having to go learn this from the beginning. It won't work. It would seem, and this makes sense, we didn't have any inventories and we produced 300 that month, so production was 300. And if you look at the formulas, you can see we can copy this for every month. No reason that formula wouldn't work for every month as long as we have those ones and zeros and negative ones right. So now all we need to do is start filling in all those ones and negative ones elsewhere. Okay. So I'm going to use the same logic. Now I'm going to June. I'm in my row June. And I know that for June, demand for June, right-hand side, already got that, has to equal production in June. So plus production in June, so I'm going to go 1 under production in June, where the blues are, plus inventories in the previous month, so inventories in May, 1 under inventories in May, minus inventories for the current month, June, so minus 1 here. And you'll notice there's a pattern going here. If you can keep doing this, like, so if there's a 1 there, there's a 1, negative 1 there. So if there's a negative 1 there, negative 1 there. So we can go negative 1, negative 1, negative 1. If there's a 1 there, well, there was a 1 there as well. Keep following the pattern. There'll be a 1 here. There'll be a 1 here. But now, we don't want to put 1 over here because that has to do with production. And now I'm going to show you why I started with the last month. Suppose we're talking about for March. This equation for March says that the demand for March should equal production for March plus inventories in the previous month, but I haven't given you any information about that. Haven't said anything about how much inventories you're starting with. So we're just assuming our beginning inventories are 0. And to make that clear, we can easily add it in, but for now I'm going to say, over here I'm going to make a note, we say assume I ending inventories in Feb equals 0. Now, if I wanted to, if you said you were actually starting March with 20, so ending inventories in February were 20. There's no I for 20 here, and so you can just subtract it from demand. That'd be a way to do it, but don't worry about that right now.
So your March production is staying at 0?
I'm sorry?
Your March production is staying at 0?
Well, March production won't necessarily stay at 0, but we're starting March with no inventories. That's all we're saying. Oh, we got to fill out over here too, so we haven't filled this out for production. And typically, whenever you run one of these models and it doesn't give you a sensible answer, you just hadn't done these ones and zeros right. So just like we've seen before, if there's one there, there's one there, you can follow the logic, logic, logic. Again, to see this is the March row, and this should equal, it's not production anymore, it's something else. We can just say left-hand side, right-hand side. Okay, I don't know if everything was finished with this. I'm just going to run it real quick and we'll see, and then I can come around and help people to run it. Okay. Solver, I'm going to check everything. So my objective function, well, the way I froze panes, I can't see it. Okay. Objective function, B1, total cost. We want to minimize it. By changing sales, all our decision variables here. We're going to change our constraint. We'll select it, say change. We want our left-hand side not greater than or equal. We want to equal to the right-hand side. Let's just see if it works. Constraints look okay. One way to see if it actually works is, let me set all my holding costs to 0. Because production got expensive towards the end of the month, so it should want to carry inventory if holding costs are 0. Yeah, okay. So this is the last thing that I'll go around and help. So way I checked it, I noticed I set this up this way. I said it's cheapest to produce in March. It's free to hold inventory. And so Excel said, well, produce everything you need in March. And that would make sense. I come over here. All these equations look right. Over here, I start with inventories. Inventories go down. Inventory should be 0 in July. There's no reason Excel would want to produce a unit that's not being sold. So I think everything looks good there. Okay. I'm going to stop there. If you wasn't able to get this, let me come around and help you. Otherwise, you're good. It's going to be like this for almost the rest of the semester, so you definitely need to come ready to keep up and stuff. Okay, hold on, let me cut this off.